So hello, welcome. My name's Bea and I'm a developer with Nokia. I'm based in Brisbane, Australia, and I'm part of the QML core team there that's working on the core QML libraries. And I'm really excited today to bring you some of the things we've been working on for QtQuick 2, which is part of the Qt 5 release that's scheduled for next year. So this is all code. The things I'm going to show you are all features that aren't actually in any released version of Qt yet. This is all cutting edge stuff, but you can actually find it already in the Qt 5 repository online in Gitoris. Out of curiosity, has anyone actually tried out any QtQuick 2 code already? Oh wow, a few of you. Great, great. So those of you prepared to be completely unsurprised today. Sorry. Okay, so while I'm sure many of you are familiar with QtQuick, let me give you a quick 2-minute overview just to bring us into context. So the goal of QtQuick is really to allow you to easily make apps with fluid user interfaces. So by this I mean UIs that feel dynamic and responsive. You can flick a page with your thumb and it slides off the screen like it's responding to your touch. Or you've got UIs that have subtle animations and effects. So when a new item arrives in a list, instead of just popping in, it slides in or fades in. And you've got UIs that don't have traditional interaction, like for desktop apps. So instead of just using keyboard and mouse interaction, you can, say, use pinch and zoom touch gestures to zoom images. So I'm really talking about custom UIs that don't look and feel like traditional desktop applications. So how do you create a QtQuick application? Well, first of all, you describe your UI with QML, a declarative language. So you can use items to, you can use anchors to lay out your items so that they dynamically resize and move with other items in the view. You can easily add animations. So you can say an item has these different states and apply these transitions or animations when they change from one state to another. And also QML makes it really easy to build your UI out of reusable components. So if you've got some code that says a button has this sort of look and behavior, just drop it in a file called button.qml and then you can use lots of button types objects in your UI. While you're creating your QML UI, you can use JavaScript or even C++ to add some imperative logic. So you can say, okay, run this JavaScript code when this signal is emitted, or use JavaScript to do your property bindings. And finally, a real strength of QML is the ability to integrate it with C++. You don't have to say, okay, I've written my UI in this language, now let me completely rewrite it in this other language so I can use it with my application. Since the QML engine is written in C++, you can just hook your QML and C++ components directly together. And you can write your QML, use QML to write your UI and C++ for your application backend, and then just hook them together. So the QtQuick 1 module, which is the currently released version, has a bunch of stuff. There's some elements for visual items, like image, text, flickable to build up your UI, do animations, handle user input, do models and views. For JavaScript integration, you can access all the standard objects like math and date, run some JavaScript in another thread. And for C++ integration, you can easily register and define your own custom QML elements in C++. And the Qt declarative module also has a bunch of utility classes for use from C++, like, for example, to load a QML UI from your C++ app. So on to QtQuick 2. For QtQuick 2, there were a number of key areas we wanted to look at. First of these was performance. We really wanted to put in a lot of work to make QML apps faster. We also wanted to add some features for QML and JavaScript integration, and also add some things to make it really easy to produce some cool visual effects and do even better animations and do drawing directly in QML. Let's look at the first of these, which is the performance. So one of the biggest changes we've made in QtQuick 2 is that we've got a new graphics stack called the scene graph, which you'll know all about if you saw Kim Cullen's talk this morning on the scene graph. So this is based on OpenGL2, and this is a very simplified model of how it works. you've got the renderer running in a separate dedicated render thread. And occasionally it sends a request to the QML engine in the main thread and says, what needs to be rendered in the next frame? The QML engine sends it back and says these are the items, the materials that need to be rendered in the next frame. And the renderer does some optimizations, reorders the tree, and then renders the scene. Naturally, this frees up the QML engine in the main thread to do things like advanced animations, process some JavaScript, etc., without being delayed by the renderer. So the scene graph gives us some huge performance benefits over the rendering model used in QtQuick 1. Aside from the fact that it's in a separate thread, which we didn't do for QtQuick 1, there's some other advantages in how it's been designed. Let me explain. So in QtQuick 1, the rendering engine that we used was the same one used to render your Q widgets, your graphics view items. And it was designed to render items hierarchically. So say you've got a really simple app like this. It's a grid of images. Each image has a white rectangle behind them to form the border, and they've got some text as well. If you render this with QtQuick 1, it would be rendered hierarchically. So you go to the top level item, render it, does its grey background fill, and renders the first child item, which is the white rectangle. Then that renders its own children, which has an image, some text, and then the renderer moves back up the hierarchy and renders the next child in the same way, and so on. So there's some unnecessary drawing going on here. First of all, we're rendering the parts of the white rectangles that aren't even seen in the final result, and same with the grey areas that are behind the white rectangles. We don't really need to draw all that if we're not going to see it in the final scene. And also, this really isn't an efficient way to render with OpenGL. What you want to do with OpenGL, of course, is to do some expensive setup to, say, draw images and then draw a whole bunch of images, or do some setup to draw text and then draw a whole bunch of text. But what we're doing here is just saying, OK, we want to draw images and we're drawing a single image, or we want to draw text and just drawing a single bit of text. It's really a wasteful use of resources. And the scene graph lets us resolve these issues in QtQuick 2. It can say, OK, now here are all the images that need to be rendered in the scene, and render them all at the same time. And here's all the solid fills that need to be rendered, and we'll draw all of them at the same time, and all the text. And it can also draw opaque items from front to back, so that you draw the images first, and then the solid fills, and then you won't draw the content that's actually hidden in the final scene. So in short, the scene graph just gives us some great performance advantages. If you saw Lars' talk this morning, you'll see a graph that showed some of the performance advantages we got with the scene graph. And especially if you have a QtQuick 1 app that's sort of similar to this, where you've got lots of different items of different types and they partially cover each other, then you're likely to find a really good performance boost. So with this introduction of the scene graph, we've got some API changes. The QDeclarative item and QDeclarative view in QtQuick 1 bound strongly to some public classes in the graphics view framework, so we've ported them to the scene graph, and they're now called QtQuick item and QtQuick view, as of some changes done on Friday. And there's also a bunch of QSG classes for modifying scene graph nodes. So there's QSG node ones and other classes for doing transforms, materials, basically for just creating your custom visual items with the scene graph. I won't go into these because Kim Cullen's talk on the scene graph this morning already covered them in detail. So if you missed that talk and you want to know more, make sure you catch up with him. We've also done some other major work to improve performance in QtQuick 2. Instead of using JavaScript core as our JavaScript engine, we're now using Google's V8 JavaScript engine, which is used in Chrome. And with our testing, we just found it to be faster, more memory efficient. It's got better garbage collection, and it's got a cleaner API that we can integrate directly with from our QML engine. So in QtQuick 1, we use JavaScript core only through the QtScript module, and that additional wrapper layer adds a bit of a performance hit. And additionally, just being able to use the V8 API directly from QML allows us to use some other V8 API features later on without too much hassle. We've also worked to increase the compile. We also parse and compile QML faster in QtQuick 2. We've got some threaded compilation going, and we've also got better optimizations for property bindings. We've also been working on asynchronous object creation, so you can now, if you're creating a lot of objects, you'll be creating a QML object tree across multiple frames, so that you obviously get a performance. It'll be faster when you create a whole lot of objects because it won't be freezing your UI. There's also other performance changes that I haven't added here. So for example, we're working on list model optimizations. For loader, you can now load your items asynchronously to avoid blocking the UI. So in short, performance is a key area that we're really focusing on for QtQuick 2. Let's look at some of the QML and JavaScript integration features. So in QtQuick 2, you can now directly access the JavaScript engine for QML app. We've got these new classes called QJS Engine, JS Value, JS Value Iterator. And basically, if you're familiar with QtScript and you know the classes called QScript Value, Script Engine, Script Value Iterator, these are the three classes that basically port those to the V8 use in QtQuick 2, since we're not using JavaScript Core and QtScript anymore. So these classes have most of the functionality of the old classes in QtScript, but the only things we've left out are things that just tied too closely to JavaScript Core, or they're just too low level, and we don't really want to expose that detail. So QJS Engine is now the parent class for QDeclarative Engine in QtQuick 2, and you can use it to create your JavaScript values and so on for your QtQuick app. Another thing we've added is a property var type. Basically, if you use the variant type in a QtQuick 1 app, you can basically change to using the var type instead in QtQuick 2. What it gives you is a way to store JavaScript values directly. So if you use the variant type in QtQuick 1, basically every time you access that property, you'd have to do a conversion between a QVariant and a JavaScript value, which can be quite expensive. And also, if you would have found that probably if you stored a JavaScript array with a variant type in QtQuick 1, that you couldn't actually modify the list in place because you're actually modifying a copy of the object. So in QtQuick 2, just use the var type and you'll be all right. You can also import JavaScript files with a namespace in QtQuick 2. Just as it shows here, you just do .import, and then you'll be able to access that script and all its objects with a namespace. We've also added a module API in QtQuick 2. So if you wanted to share some global C++ functionality in QtQuick 1, you had to basically create a context object or context property, and then or register a custom QML type, and then create a special global object in the root item and access it with this special ID, which works sometimes, but it can be a bit of a pain. And also, of course, for libraries, you don't want to be always exposing context properties in case of namespace clashes. So in QtQuick 2, you just have to call this QML register module API function in C++ with a factory function that returns an instance of a Q object or a JavaScript value. And then once you've done that and called that function with this, for example, this URI, com.namespace.settings, then you'll be able to access that C++ objects as my settings and access all its Q properties, methods, etc. So here in the example, we're accessing a Q property on that object called default font family. And it's just a lot cleaner. It's a much better way to access that type of data. So that's the major features for QML and JavaScript integration. Now I want to show you some really cool visual effects features that we've added in QtQuick 2. So we've added a new particles effects module for doing some great visual particles effects in QtQuick 2. In QtQuick 1, there was a library for doing particles effects, but it was just experimental and it was very limited in comparison. So when I'm talking about particles effects, I mean things like when you want to simulate fire, smoke, snowflakes, just visual effects that involve lots and lots of tiny little particle items on your screen moving around. Oh, and I did mention on the title slide, but I forgot to talk about it, that this presentation is written in QML itself, which isn't just for novelty, it just makes it really handy for integrating demos directly into the presentation. So here are some particles effects that are written with this particles module in QtQuick 2. So we've got a simple rocket ship just going around on in space, pretty boring. We can spice it up with some stars coming out the middle. So we're just telling the particles module, here's a single star image, now make lots of copies of it. We can add some meteorites coming out as well, just for extra zing. And then we could also use particles to add a little flare of colourful exhaust coming out the back. Very pretty. We could also use particles to, say, spice up a simple list view. So here we've got some particle flowers in the background that fade in and out. And there's also some star particles following the current item. Of course, you can also use particles right in the forefront of your UI with some really strong, colourful effects. So here's one that's been written with custom shaders, which is very pretty. And here's another very pretty one with some colourful twirling particles, fireworks sort of thing. So let's look at how the particles module actually works. If you want to write particles effects, you basically need to consider these four major components. First of all, you need to create a particle system, so that will actually manage all the different objects, run your system timers and so on. Then you need a particle painter to actually render the particles. So you can render, say, a QML image or a QML item, or even use custom shaders to render your items. And then you need to create an emitter to actually create the particle objects. So the emitter can control things like the lifespan of a particle, the size of the particles, etc. And then you also need optionally you can add an effector, which will alter the attributes of particles after they've been created. So enough talk, let's dive into some code. And I'll show you how easy it is to use particles. So here's a really simple setup. We've imported the new QtQuick particles module. And then here we've got a simple 600 by 600 rectangle that's black. We've created a particle system so we can actually use particles. Here's an image particle. It'll render a really small white star called star.png. And then we've created an emitter object so that we can actually create create particle objects. And this will create particle objects with a size of 50 pixels. So before I explain further, let me just run this and see what it looks like. So there you have it. Really simple, just a few white stars shimmering all over the black background. So I want to point out that the reason that the stars fill out the whole window is that we've got this emitter here, which fills the size of its parent, which in turn fills its parent. So obviously the emitter is actually 600 by 600. So we're saying emit these particles all over this 600 by 600 window. So let's make it a bit more interesting. Let's have the particles starting at the bottom corner of the window and then spreading out. To do that, instead of filling the whole window, we'll say, let's make it 50 by 50 and anchor it to the bottom of the parent so that it comes up in the bottom left-hand corner. All right, there you go. And to actually move them out, bad spot there. Sorry? Use the
We can't see the bottom of the screen.
Oh, damn. Okay. Maybe I'll just make it smaller. But I like it from the box. Okay. Can you see that any better? Okay. Okay. Let me just move them out across the screen for you. So we just add an angle direction, and basically we say we want to move the particles out in an angle of 300 degrees and then at a speed of 150 pixels per second. Okay, that's not really moving enough because the particles by default only live for 1 second. So if we say They should move. They should live for 8 seconds each. That should be enough to get all the way across the window without dying. Okay, so we've got this set up now, but it's still a little boring, right? Because all the particles are moving in exactly the same manner. What would really make this better is if, say, all the particles move slightly different from one another. And we can do this by adding an angle variation. So basically we're saying, okay, all the particles in general are moving at 300 degrees, but they can randomly move at up to minus or plus 10 degrees either way. So that gives us a nice little effect where each particle is moving slightly differently from the next one. And I want to emphasize that this is a real strength of the particles module, that you apply certain parameters that make the particles behave in a general way, and then you apply small variations that really make the scene come alive. So we could do other variations, like say, okay, we don't want them to all be the same size. They can be up to 40 pixels bigger or smaller. And having all white stars is pretty boring. So let's say we want a variation in the color channels between 0 and 1. And this gives us a much prettier effect so that you can see there's a bit of color variation and some of the particles are bigger than others. So what else can we do here to make it even more exciting? Maybe we could say that the particles move towards the top of the screen and then suddenly fall back down. So we can use an effector to do this. So effectors modify particles after they've been created. And the particles module comes with some built-in effectors like gravity to pull particles in a certain direction, or wander to make particles sort of wander all over the place, and some other ones as well. And you can, of course, do your own custom effector effects. So let's do this effector. We'll use a gravity effector, which will basically, let me put it up. Is that text good at the back? Oh, great. All right. So if we add a gravity effector and say, okay, any particles moving up to the top of the screen should fall back down, we'll make the gravity effector the same width as the parent, so that catches all the particles. The height doesn't really matter, and then we shall set the effector at 1/3 of the way down the height of the parent. And then whenever any particles hit this effector, it should apply an angle of acceleration of 100 degrees and accelerate at 100 pixels per second. Let's see if it works. Should hit it about now and fall back down. Cool. So that's how easy it is to do your own particles effects. So this is just really basic stuff. There's lots more you can do. For example, you can have particles that, you can set your particles to belong to different groups, so that an emitter only emits one type of particle, or an effector only affects certain types of particles. And then you can also give states to different particle groups and say that, say you've got some smoke particles, and when they hit these other particles or this certain area, they should explode and become fire particles instead. You can have trail emitters, so emitters that follow other particles and emit particle trails on the back of other ones. So there's lots more you can do with particles. So, and another really cool visual effects feature we've added in QtQuick 2 is shader effects, which comes with the scene graph. So you can actually combine GLSL code directly with your QML code. And this lets you just control the graphics at a much lower level and add effects like shadows, blur, colorize, page curl, and anything else you can do with custom shaders, really. And you can apply this to both images and QML items. I think there's something wrong with the resolution. That's why. Everything seems a bit too big. Uh-oh. That's better. I was thinking why everything was so magnified. Okay, so the main elements to be aware of here are... What are you laughing at? The main elements to be aware of here are shader effect and shader effect source. So basically, shader effect lets you actually implement your custom vertex and fragment shaders, and that can take as input either an image or a shader effect source, which lets you basically render a QML item to a texture so that you can apply your custom shader effects. Let me do another quick demo to show you how to use shader effects. All right. So here's a basic setup. We've got a row with an image and a shader effect. And basically, the shader effect is set to render this image. Let me show you what this does. So very simple stuff. Here's our 200 by 200 image and then the 300 by 300 shader effect. And you can see that although the shader effect hasn't actually got any shaders set for it, it's still rendering the image. Why is that? Well, it's because it already has some default shaders written for it. If you don't write a custom vertex or fragment shader, it'll fill it in with some default shaders. Let me show you. So here's if you don't write a shader, these are the default ones that will be filled in for you at this moment. So if you're familiar with GLSL, I'm sure this is very straightforward, but otherwise, it's quite simple. Ooh. Basically, the vertex shader simply sets the GL position according to the model view projection matrix and applies it to the incoming Qt vertex. And the vertex shader will be called once for each of the vertices in the shader effect, so each of the four corners of the shader effect item. And then the vertex shader also sets the QtQuick variable here, which is used here by the fragment shader to actually sample the correct coordinate from the incoming image. So you can see that the fragment shader simply sets the GL fragment color according to the correct coordinate that's sampled from the source image. And the reason this works here is because this source variable is actually the same source property that we've defined here. So when you declare a property in the shader effect, a QML property, like this, it makes it automatically accessible to the fragment shader, which can be used to great effect. Let me just copy out the fragment shader and then let's do something with it. Let's make a really simple wobble effect with the fragment shader. And to do this, we will just modify the coordinate that's sampled from the source image using a sine curve. So let me... I think there was a patch I was meant to apply to avoid that bug. So let's say the variant, let's say the sine curve will have a frequency of 20 and an amplitude of 0.05. Now we can use that to, so let's actually access those variables, the frequency and the amplitude that we've declared. So once we declare it here, we'll be able to access it from the shader. Now we can get a point, frequency times Q text coordinate. And then let's use the transformed coordinate here, which is amplitude. I'm glad I printed this out. Okay, so that should be all we need. Let me put this on one line. All right, so that's all we need to apply a simple wobble effect. So you can see it's very straightforward to just do your own custom fragment shader like this. Of course, the really cool thing about having access to QML properties directly from your custom shader is that you can use this to make animations. So let's do that. Let's animate the wobble effect. We can just add a time property here and then say we want a number animation on the time from 0 to math.pi times 2. Animate it over 1 second and then loop it forever. Now, if we access this new time variable from our shader and then use it to modify the sampled coordinate, we can get a wobble effect. So this looks pretty good, but the thing I want to emphasize here is that you don't have to use this just for images. You can apply the shaders to normal QML items as well, using the shader effect source that I pointed out in the slide just before. So let's have a really simple QML item, a text item, say, that says hello, and we'll just blow up the pixel size a bit so you can see it clearly. And instead of using the image, we'll render the shader effect source. So there you go. You can just apply shaders to any old QML item as you like. And I do want to, I'll just show you again that, this here was created using custom shaders as well. So the particles module comes with an element called custom particle, and it has vertex shader and fragment shader properties just like the shader effect, so that you can write your own shaders for particles, which is how this demo is done. Okay, so that was shaders. Onto the Canvas API. In QtQuick 1, if you wanted to do your own custom painting, say draw lines and shapes in QML, you'd have to go to C++, subclass QDeclarative item, and do your own custom painting with the QPainter API. And in QtQuick 2, you don't have to do that anymore. You can do this directly in QtQuick 2 with a canvas element, which is basically based on the HTML5 Canvas API for drawing. You can draw lines, shapes, paths, text images, and you can also manipulate specific pixels in the canvas. So here's a few examples. You can draw some basic shapes like straight lines, curves, arcs, Bezier curves, quadratic curves, and whatever other curves there are. And you can also draw images. So you can say, here's a QML image, please render it in the canvas for me. And then you can use the Canvas API to manipulate specific pixels, like for, say, to apply a brighten effect or apply some blending filters or make it grayscale or whatever you like. Aside from integrating with QML image, you can also render QML path objects directly in a canvas, which can be really handy. So in QtQuick 2, we've got a new path element called path SVG, and you can use this to actually load a complex SVG path into a path object. And combining this with the ability to render a path in a canvas, you can actually do this to, say, load a fairly complex SVG path directly into a canvas. So here we're just rendering an SVG path bit by bit using the canvas object. Oh, I also want to show just this little example that we ported from a HTML5 canvas app on the web, openrise.com. So it's really neat because it combines the ability of the Canvas API to draw paths with the ability to manipulate specific pixels in the canvas as well. And as you can see, you can use this to create some nice effects. So to use the Canvas API, all you need to do is create a Canvas object and then override the onPaint signal handler. And once you've done this, you can get the context like you can with the HTML5 canvas and then draw your rectangles, lines, and whatever else. So this example just produces a small rectangle like this. And so onPaint is called automatically when the scene is first rendered or when the canvas is resized. And you can also call update paint request paint if you want to manually trigger a fresh call to the onPaint signal handler. And the Canvas API comes with some other rendering options as well, so you can either render to a QImage or an OpenGL frame buffer object. And it's also got a tiled rendering option, so if you say want to zoom in to a specific area of the canvas and just render whatever's visible and not render the rest of the canvas until it's flicked into view. In QtQuick 2, we've also added path animations, which is really cool. Vote for path animations. So in QtQuick 1, if you had a path object, that mainly revolved around the use of paths in path view. But in QtQuick 2, you can also use it for animations. Excuse me. So the main elements here are path animation and path interpolator. First of all, we've got path animation, which makes it really easy to animate an item along a path. So you can just give it a target item and a path object, and it will move it along the path for you. Here's a really simple example. We've got a little ball that moves around in a path. So this is a path object that's been rendered on a canvas, and then you just pass the path and the ball to path animation, and it will move it along for you with the specified duration. The other item you can use for animation with paths is path interpolator. So instead of giving it a target item, and it's actually got its own progress property, which you can animate or change between 0 and 1. And whenever you change it, its X, Y, and angle properties will automatically change to be the correct values as per that point in the path that you've specified with the progress property. I'll show you a quick example to see the difference between this and path animation. So this is done with path interpolator instead. And basically, we're just animating the progress property from 0 to 1. And because of that, we can actually do effects like change the opacity of the item depending on the progress. And we can set the progress to particular points along the path so that you can know the exact X and Y values that should be correct for the item at that point in the path. And while this is a pretty trivial example, I want to point out that path animations can be really cool for things like, say, adding a new item to a view. You can have it animate in along a path to its destination instead of having a straight linear path like with a number animation or something like that. And finally, we've improved the text rendering in QtQuick 2. So with the scene graph, we get some great performance boosts for text rendering and rich text rendering in particular. And we've just recently added a feature for doing some nice text effects. So you can override this on line laid out signal handler to change the line width of text on the fly. I'll clarify that with a little demonstration here. So here we've got some rich text, and then we can actually use the signal handler I just mentioned to change the line width on the fly. That's just pretty neat. Okay, so that's the end of the features that we've got for QtQuick 2. Let me summarize really quickly. So in QtQuick 2, the areas we wanted to focus on was performance, JavaScript integration, and some features for visual effects and animations. For performance, we've got a new scene graph stack, so a completely new rendering engine on the bottom, and then we've changed our JavaScript engine from JavaScript core to V8, and done lots of other core engine optimizations as well. In terms of JavaScript integration, we've got direct access to the JavaScript engine for QML app in QtQuick 2, and there's also a module API to make it much easier to expose C++ functionality. And of course, we've got some elements for doing some better visual effects, like particles, shaders. You can draw directly from QML with the Canvas API, and other things like path animations and text effects. So I hope you're all really excited about QtQuick 2 now, and you really want to go out right now and check it out. So you can do this by looking at the Qt 5 repository here on Gitorious, and you might also like to join this Qt 5 feedback mailing list, which has lots of discussions on Qt 5, including QtQuick 2. So, I mean, I did want to say too, there's some features in QtQuick 2 that I haven't been able to mention yet, just because there was all this content I wanted to cram in. And there's lots of other things we're working on as well, like drag and drop touch areas for multiple touch points and things like that. Anyway, that's it. So thank you. Any questions at all?
Are there any limitations to the platforms this currently runs on?
It runs on whatever Qt 5 supports.
And what's that at this stage?
What?
What's that?
Windows, Mac, and Linux.
So it is running on Windows?
Oh, no. Mac and Linux. Why are you asking me trick questions? -1 point for you. A question at the back.
Is the Canvas API using the software rasterizer, or is hardware rasterizer?
It's using scene graph directly. There's no extra layer in between.
Okay, so it's directly using OpenGL to draw a line.
As far as I'm aware, yeah. I mean, I can check the exact details for you if you like, and get back to you.
Because I guess in that case it will use the render to texture path or something like that.
I'll have maybe I should get the exact details for you later. I mean I'll rather clarify. Yeah.
Okay, thank you.
Please tell me, can I? So I'm so impressed by your presentation that I want to use QtQuick 2 right away. Is it possible?
Yeah. So if you download,
so get Qt 5 and compile it. Yes.
Yeah. So all the QML code lives under the Qt declarative module. So if you don't want to compile the whole of Qt 5, you should probably only need Qt base and Qt declarative, and then you'll be able to get up and running, yeah.
Hi. I was looking at the animations, and the frame timing seems that it has an artifact now and then. I thought that was solved with QtQuick 2.
I'm not sure. Like, I know when I practiced this talk back in Brisbane, there was a problem with the projector that it was jerky on the projector, but not here. So maybe I can show you here. I'm not sure which animations you're referring to, and see if it is happening or not.
Oh, great.
Yeah. Which animations were you talking about?
It was mainly the stars. It was easier to see there.
Okay. Yeah. I know that was the one that was triggering some problems with the projector when I was trying it out the other time. So it could be the same, but I will check with you.
But it's solved.
Yeah. When I run it on here, I don't see the jerkiness. So yeah. Just one just over there.
The Canvas API, is that like compatible to the HTML5 Canvas API, or like can I just take the HTML5 Canvas code and plug it into QML and it will work?
You might have to do some modifications depending, of course, like if the HTML5 code accesses some DOM elements or something like that, you know.
Okay,
you might have to, but mostly I believe it's pretty straightforward, like with minimal code changes.
Okay, thanks.
I mean, the other difference, of course, is that in HTML5 with the canvas you can get a context wherever and draw it, but here you've got to do it in the on-paint signal handler and stuff like that. Yeah. Any more questions at all? Last chance. Oh, one here.
I've always had some issues with drawing text and transformations. Is this still an issue? Basically, often if I have some separate component including text and it's scaled, and the text typically doesn't scale that well. Are there any possibilities for optimization there? Because the text is typically rendered in the fixed size for the original size, and then if it scales, it gets blurry or something.
Okay, I'm not sure of the exact issue. So you mean just scaling text is...
The point is that the text is rendered in the original size and then scaled instead of basically collapsing the scaling into the text rendering and rendering at the final size.
Okay. I'm not sure about the exact issue there, sorry, but I'd be happy to... Oh, great. Here's Kim, the expert on scene graph.
Text rendering in QML scene graph works with distance fields. So the font cache uses a distance field, which scales perfectly.
Fantastic. That's it. Thank you. Thank you very much.